In this video, we're going to discuss scientific notation, which is just that. It's a notation. It's a different way of writing the same number. So a positive number is written in scientific notation if it is written as the product of a number A, where 1 is less than or equal to A, which is less than 10, which means that A is between 1 and 10. The number is between 1 and 10. And an integer power R of 10, which means 10 to the R, 10 to some number. So it's a way to write really big numbers or really small numbers and kind of a easier way to read them. So the first example they give us is 76,300. And what we said is that A, the first part of it, has to be between 1 and 10. It can be a decimal, but it has to be between 1 and 10. So we're going to look at this, and our decimal right now is here. And basically, we're going to move this decimal, 1, 2, 3. If I stop here, I would have 76.3. And that's not between 1 and 10. So I need to go 1 further and stop here. If I went even further, then I would be less than 1. So right now, it's 7.63 times, and I need to write 10 to some power. And then we're going to count. 1, 2, 3, 4. How many times did I move? 4. If I multiplied this out, it would be the same number. It just looks a little different. Okay, so using the same idea here, except this time we have a very small number, and we want to try to write it in scientific notation. So the first thing we want to do is find A that is between 1 and 10. So if I start with my decimal and I start moving it, if I stop here, I have 0.27, which is less than 1, so that is not between 1 and 10, which means I need to go 1 more and put a decimal here, which would give me 2.7 times 10, and then I'm going to count again, 1, 2, 3, 4, 5, 6, but this time it's going to be to the negative 6. Because it was a decimal, it's small. So we use negative numbers for a decimal, and we use positive numbers for a large number. Now, going the other way, 3.184 times 10 to the negative 4. So a negative exponent, remember, is a small number, which means I'm going to move my decimal place to the left. 1, 2, 3, 4. And now I'm going to put a new decimal place. And anywhere that there is an empty bump, I'm going to put a 0. So my answer would be 0.1233184. Same idea with a large number, because this one has a positive exponent. So it's going to be a large number. I'm going to go 1, 2, 3, 4, 5, and that's where my decimal place would be. Anywhere there's no number, I'm going to go ahead and write a 0. And so my answer would be 867,000. And again, this is just a notation. It's just a way of writing numbers in a different format. Moving on to polynomials, we're going to cover some definitions that are really important. A polynomial is a finite sum of terms of the form ax to the n, where a is a real number and n is a whole number. So where a is real, which is all the numbers you're used to working with, and n is a whole number, so it's not a decimal. A monomial is a polynomial with exactly one term. So look at the word breakdown. Mono, right, is 1. Mono a mono. So that's one term. Binomial, again, bi is 2, like a bicycle, 2 wheels. And then a trinomial is a polynomial with exactly 3 terms. So tri is 3, like a tricycle, 3 wheels, right? 3. A polynomial is written in descending order if the powers decrease from left to right. So that means that you have something like ax squared plus bx plus c. My powers are decreasing from left to right. Goes from 2 to 1. Okay? The degree of a term is the sum of the exponents on the variable in that term only. The degree of a polynomial is the highest degree of all the terms in the polynomial. Those are both kind of wordy, but we're going to just do an example and see if it makes sense. Degrees of each term in the polynomial. Find the degree of the polynomial and classify the polynomial as a monomial, binomial, trinomial, or none of these. So first we're going to start with the coefficient, which is the number in front of the variable, in front of the x or the y or whatever it is. So 6, -4, and 3. You would keep the sign to the left. So 6, -4, and 3 would be our coefficients. Then it says find the degree of each term. So this one has 3 terms because terms are separated by addition and subtraction. So 1, 2, and 3 terms. The degree of each term is the sum of the exponents on the variables in that term only. So for the first term, there's only one variable, it's x, and its exponent is 5. So the degree of the first term is 5. On the second one, there's still one x, and the degree on that one is 4. And on the third one, there's still one x and one exponent, and so that one would be 2. So then it says find the degree of the polynomial. The degree of a polynomial is the highest degree of the terms in that polynomial. So now we want to look at these and say which one is biggest. 5. So the degree of the polynomial is 5. And then last thing is we want to know if it's a monomial, binomial, trinomial, or none of these. And that goes back to how many terms there are. This one has 1, 2, 3. So back to our word breakdown, which one meant 3? Trinomial. Okay? So now we're going to get a little bit more challenging. This one's a little bit bigger. 17x squared y cubed minus 3x cubed y z to the 4th minus 5y to the 6th plus 11. Okay? So first we're going to write the coefficients. We have 17, -3, -5, and 11. Okay? Next, the degree of each term. Remember, this is one term, this is one term, this is one term, and this is one term. So the degree of the terms is the sum of the exponents on the variables in that term only. So this one has an x and a y, so we're going to have 2 plus 3. So the first term would have a degree of 5. The next one has an x, a y, and a z. So we have 3 plus 1, that's not written, plus 4. So 3 plus 1 is 4, plus 4 is 8. This one only has a y, so it would be 6. And this one doesn't have anything, so we could say that it has an x to the 0 power, because remember, x to the 0 equals 1. So this one would have a degree of 0. Okay? Now it says find the degree of the polynomial. So the degree of the polynomial is the highest out of these. Which one's the highest? Hopefully you said 8. And then lastly, it says classify the polynomial as a monomial, binomial, trinomial, or none of these. So we go back to how many terms do we have? 1, 2, 3, 4. Do we have any that said 4? No, so we would say none of these. It's just a polynomial. To add polynomials, combine all like terms. To subtract polynomials, change the sign of all terms of the polynomial being subtracted and then add. Okay, so first for adding, we're going to look, we have 7y cubed minus 2y squared plus 3 plus 6y squared minus 5. So we got to combine all like terms. Like terms mean they have the same variable, x, y, l, whatever letter it is, and the same exponent for it to be like terms. So first we're going to look at 7y cubed and see, is there anything else that has a y to the third power? No, so we're just going to write 7y cubed. Next, we're going to look at negative 2y squared. Is there anything else that has a y squared? Yes. So I'm going to write negative 2y squared plus 6y squared. And then I'm looking at just my numbers. So I have plus 3 and my minus 5. So plus 3 minus 5. And now I'm going to combine. So I can combine negative 2 plus 6, which is like 6 minus 2, which is 4y squared. My 7y cubed just comes down. This one should be a plus because the 6 was a plus. And then I have 3 minus 5, which gives me a negative 2. And this would be the final answer. I cannot combine anything else. Okay. For subtraction now, it says change the signs of all the terms of the polynomial being subtracted and then add. What that means is I'm going to distribute this negative through to each term. It's kind of like I'm multiplying by a negative 1. So a positive 8 by a negative 1 would be a negative 8m to the 7th. Negative 4m to the 4th times a negative 1 would become a plus 4m to the 4th. And then a plus 6m times a negative 1 would be a negative 6m. The first one does not change. I just rewrite it down. Now, I look again for like terms. Which ones are the same? The first one has an m to the 7th. Is there another m to the 7th? Yes. So I'm going to write these next to each other. And it might be that once you get more comfortable, you can just do the math, but I'm going to take an extra step. Then we have m to the 4th and an m to the 4th. So I have plus 3m to the 4th plus 4m to the 4th. And then just 1 minus 6m. So now I can combine. 2 minus 8 gives me a negative 6, and my variable does not change. It's just m to the 7th. So think about it like if I have 8 oranges and I eat 2, then I have 6 left. So think about, it's like I'm talking about something. 8 oranges or 2 apples. But right now I have 2m to the 7th minus 8m to the 7th. Plus, I have 3m to the 4th plus 4m to the 4th. So 7m to the 4th. And then there's nothing to combine the last one, so minus 6m. Again, we're going to stop here because nothing else can be combined. And that would be your final answer in my math lab.